All right, class, let's head back to our seats and let's regroup. Let's talk about what we proved and let's see if we can all get on the same page about parallelograms and their diagonals. So, since we're talking about the diagonals, let's draw those in. There we go, one of them. And there we got the other one. Perfect. So, we're working with a parallelogram. What do we know? Before we start to prove anything, what are we given? Yes, the definition of a parallelogram. Can anybody give me a definition of a parallelogram? Yeah. Two pairs of congruent sides. I like your thinking. So what does that mean exactly? Is this a parallelogram? We've got two pairs of congruent sides. No, I think most of you agree that's not a parallelogram. So, how do we be more specific about that? Two pairs of opposite congruent sides. So, something like this. Does that work? We have these two and these two congruent. Yes, I think we all like this drawing a little bit more. Now, I have a question. Is it possible to have a parallelogram with four congruent sides where all the sides are congruent to each other? I see a lot of you nodding yes. Yes, I actually noticed that a lot of you put squares as one of your examples, and squares have all congruent sides. So yeah, you can also have a parallelogram where all the sides are congruent to each other. But we're just going to focus on this example because we could just do that and then all the sides are congruent as well. Now, saying stuff like this side and this side and this side and that side, that's not really specific, is it? And if I ask you questions, it's kind of hard for me to tell what you're talking about if you're just pointing and saying that side. So I think we need to be a bit more specific with our parallelogram. I actually really like the idea that Peter had where he labeled his parallelogram with letters. So he labeled each of the vertices with A, B, C, and D. Peter, why did you label your parallelogram? Yes, it's so much easier to be specific about which angles and triangles you're talking about if you label them. So we're also going to label this point here in the middle where AC and BD meet. See how much easier that is to tell? I'm talking about AC and BD. And we're going to label that as point E. So now we have our labeled parallelogram with some things that we know, like the opposite sides being congruent. So what can we do with this information now? Okay. Tim says that we can use vertical angles and we can get some congruent angles on the inside of our shape. So, what are we saying? Angle BEC is congruent to angle AED. These angles right here, right? Yeah. And you're also saying that AEB, this one over here, is congruent to DEC. So we're saying that the red angles are congruent to each other and the blue angles are congruent to each other, right? Yes. And that's because of vertical angles. All right. What else can you say, Timothy? Okay. Now let's repeat what Timothy just said. He said that triangle CED and triangle AEB are congruent because they have a side and an angle that are congruent to each other. Do we agree with that? Heather says no. Heather, can you explain why not? Okay. So they have a similar side and a similar angle, but only one of each. Right. So what can we do to get a bit more information than that? Alternate interior angles. I actually saw quite a few of you use alternate interior angles. I think Peter also used this. So Heather says, first of all, let's talk about what alternate interior angles are. What do we need for that? Two parallel lines. So which lines are parallel? It's a parallelogram, you're right. So the opposite sides are parallel to each other. So we can say that line AB and line DC are parallel. Yes, I see you all nodding your heads. Good. And then we can say that line AD and BC are parallel to each other. Okay. So we now have our two sets of parallel lines, and how can we use that with alternate interior angles? Okay. Heather says that because of alternate interior angles, we can say that angle, you said BAC? BAC and ACD are congruent to each other. So do you notice anything interesting about triangle BAE and CED? These two triangles right here. What's interesting about that? Angle, angle, side. Yes. So we have these two angles. The green ones are congruent to each other and the blue ones are congruent to each other. And we also have a congruent side because it's a parallelogram. So that tells us that this side between these angles is congruent, right? To this line. So these two lines are congruent. And it tells us the same thing about this last line right over here. So, and this one down here. So we know that line segments AE and EC are congruent, and line segments BE and ED are congruent. All right. And now I think we can notice something interesting about the other two triangles, triangle AED and BEC. What can you tell me about those triangles? Yes, exactly. We have side, side, side now, which tells us that these two triangles are also congruent with each other. So, a lot of you actually proved that the triangles that are sort of opposite to each other, right? They share a vertical angle, that they're congruent to each other. So if we label these triangles 1, 2, 3, 4, we can say that triangle 1 and 4 are congruent. 1 and 4. See that squiggly symbol I drew right there? That is a congruence symbol. That means they're congruent. You don't have to worry about that just yet. You can just write an equal symbol, but just so you know, that's how you write that. And then we can also say that triangle 2 is congruent to triangle 3. Okay. So now what does that tell us? Let's look at the diagonals, since that's what we were mainly focusing on in this lesson. So this line right here and this line right here. What does that prove about the diagonals? If you want something to look at, maybe to take a look at line segment DE and EB. What do you notice about them? Yes, they're congruent. And same thing here at AE and EC. So when these two diagonals sort of hit each other, when they intersect, they split each other in half. Isn't that kind of cool? And this is true for basically every parallelogram. See, we didn't include any side lengths here, and we just used stuff like side angle side, because no matter what parallelogram you use, the opposite sides are always going to be congruent to each other, right? And the vertical angles are also always going to be congruent to each other. And because they're parallel lines, we're also always going to have alternate interior angles that are congruent to each other. So this will work with every parallelogram because of those triangle rules that we know. Yeah. And you guys all helped prove this with all the work you did. I saw a lot of you talking about how they're congruent, and I saw so many of you using triangle congruence theorems. This was a great first step into learning proofs. I'm really proud of you guys.